Second year now,
All
I
right.
do not understand what that means.
Yesterday's video, I said with the utmost love, of course. But 30 says
I think I started them just because to make sure I was right.
y equals pi over 5x squared. So what we are doing is we are finding derivatives, right? We're
Yes.
first using derivative rules, right? And these are some of our homework problems that we are doing. A rewrite is always in order. And we don't know how to deal with something in parentheses right now, but we can. It's multiplied, right?
Yes.
Can we square the 5?
Yes. So it's
25. X squared on the bottom. Agreed? We need to rewrite one more time. That x squared on the bottom is the same as, to the negative 2, you mean. 1/2 would be a square root, right? But the pi over 25 can be just thought of as a coefficient.
Is it okay if I did that in one step?
It is okay if you saw it in one step. Yes, I would have seen it in one step. But now we're ready to differentiate, right? Take the derivative. What's the thought? Power down in front. Nothing reduces. Negative 2 pi over 25, right? What is it when we lower the power by 1?
X to the negative 3.
Yes. So there's the differentiate. And then it also says to simplify, which would mean probably get rid of the negative exponents. So take that x cubed to the bottom.
I was just confused.
That's
with
what they did for the final.
Negative 2.
It was an even problem, so I didn't know if we got it right or not.
Yeah. What was your comment?
I just didn't know how to use the negative 2 in front.
Okay.
Don't do it.
Just keep it there. Or multiply it through or whatever. X cubed minus 3x squared plus 4 over a single x squared. I'm here to tell you that even when we move into product rule and quotient rule, if we have a single term on the bottom and multiple terms on top, a rewrite is always good. Now, we can rewrite it and show it as x cubed over x squared minus what? 3x squared over x squared plus 4 over x squared. Divide those out. So we're still rewriting. I'm still calling it f of x, right? What is x cubed over x squared?
X
What about x squared over x squared?
minus
Let's keep it minus 3. How should we write 4 over x squared?
4x.
Everybody see that? And now take the derivative. Derivative of x is 1. Derivative of a constant is 0, right? And the last one would be minus 8x to the negative 3. That, to me, is a perfectly fine answer. I have a feeling the back of the book might have gotten a common denominator, and they would have had x cubed minus 8 over x cubed.
No, it was that.
They gave this first one?
Yeah.
Proud of them.
I multiplied the x to the negative 2 to everything instead of splitting it up.
But it still gave you this.
No, they did the second one.
Well, I was confused because I got negative 6 to the negative first.
All right, so if you, instead of writing it as 3 separate fractions, if you said distribute x to the negative 2 times x cubed minus 3x squared plus 4, then you would have still gotten x to the first for the first one, correct? And negative 2 and positive 2 cancel, minus 3 for the second one, and 4x to the negative 2. So had you done proper algebra skills, you would have still had the same answer. These are definitely two equivalent ways to think of this problem, right? 57 says find an equation of a tangent line to the graph. Use the graphing utility to graph the function and its tangent line, and then use the derivative feature to confirm. We use the draw feature to confirm, right? But g of x equals x to the fourth minus x. So if we're writing an equation of a tangent line, we need a point given, and we need a what? Slope. How do we get the slope? The derivative, which would be what? 4x cubed minus the plain old 1.
Oh, it's one. I did
You keep
X
trying to
is
put 0. Yeah. Derivative of x is 1.
Yeah.
If you wanted to add that to your little list of rules, you could. Derivative of x is 1. But if you take the power 1 down in front and lower the power by 1, 1 times 1 is still 1. So what are we going to plug in? What value? The -1, the x value, right? -1 cubed is -1 times 4. -4 minus 1 equals -5. So now we have our slope and our point. Y minus y1 equals slope. X minus x1 would be plus 1. Free response it, be happy. The book may have distributed. I know, I'm the same way. If I'm doing it for my seat, do you see the mistake I made? I would have not gotten my multiple choice answer right. That could be a multiple choice. Guys, they could also have made it 5x plus y equals -3, right? Sometimes I've seen 5x plus y plus 3 equals 0.
I'm pretty sure they did that in the back.
Which one?
The last one.
I've seen those, yep. But sometimes they do y equals mx plus b form. You just never know. 60. Oh, it has a trig function in it.
It's ugly.
It is not ugly, it's beautiful.
Not decimal.
Actually, I agree with you.
It's kind of.
It's kind of ugly. Especially because there's an e to the t. If it was just the sine function, the trig function, it wouldn't be that big of a deal. But we're plugging in a pi for our x, right?
To the pie.
E to the pi. And it even shows us that for the y value, right? So the derivative of sine of t is regular cosine t. What's the derivative of e to the t? E to the t. Keep the 1/2 in front, right? So again, to find the slope of the tangent, plug in our pi. Cosine of pi. Go to our cosine curve if you need to. Starts off at 1. At pi over 2 at 0. So where is it at pi? -1. -1. Plus 1/2 e to the pi.
Put that in the calculator.
Well, if you're going to use your calculator, you might as well have done it all on the calculator to me. But I just go ahead. Y minus y1 equals slope -1 plus 1/2 e to the pi x minus x1. Stop. Don't even try to do anything else.
Is there gonna be a question like that?
Heck no.
Good.
But now the kicker would be putting the function in the calculator. I know they said actually graph the function and its derivative, right?
We'll find the derivative.
E to the x. Is it okay to call the t's x's?
Yeah.
Yes, it is. So there's our function.
Well, that's strange.
Pi is 3.6, so at least pi is showing on here, kind of.
Well, that's,
We might need to see a few more y's.
I think.
Let's go to 15. All right. So if we put in our equation for the tangent line, is it okay to just think of moving, I'm gonna put the whole right side in, -1 plus 1/2 e to the pi. Error right, times x minus pi. And then I'm just gonna add the 1/2 e to the pi. So let's see if it looks good. There's my drawing.
Where is it? Oh, there it is.
It's showing up.
That looks like.
Looks pretty, looks like a tangent line.
Wow.
It's hard to tell
It kinda
completely.
looks like it is gonna intersect.
Kind of looks like it, but I guess we can go up to 20 and see if it really does look like that. I just dropped off some of the lower y's.
Why does it take so long for it?
I don't know.
Uh,
Pretty daggone good. So, now I'm going to come down and I'm going to unhighlight my tangent line. And remember the first way I showed you to get your calculator to just graph the tangent line. Do y'all remember? From the graph screen. Second program, draw. Number 5. Sorry.
and you type in.
At x equals, what was the x value? Pi. Enter. Looks exact. Oh, did you see how fast that tangent line was drawn? That one was y equals 10.570348x minus 21.63 ... So how do we know, sorry. How do we know if our equation is exactly the same?
Who knows?
Do you plug in?
Yeah, I'm gonna plug in these values. Now, I guess to get this slope, I could just plug in that value, right? -1 plus 0.5 e to the pi, right? Well, lo and behold, got that part right. To get the y-intercept, would I have to multiply this by pi, and then add 1/2 e to the pi?
You just.
Because this is, I'm distributing, right? So I'm going to multiply that by pi. And then I'm going to add 0.5 e to the pi. It was negative here. When I take it over, it becomes positive, right? Mm.
Because the negative pi on the other end, x minus pi.
Oh, that was a negative pi.
it's not
So this would have been a negative number plus. All right. So here we go. I'm going to come up here, multiply it by -1, then add 0.5 e to the pi. The hard way. -21.63 ... All right. And the other way, just to see if we got our slope right. How do we go straight to just the slope? Math 8. arrow down so you see what 8 looks like. Oh, let me show you how to do it on the 83 also, because it's yucky. On the 84s, you just put in your x, you put in your function that was already in y1, right? And the x value is pi. Oh, second trace gives you the function, right, at pi. 10.5703, same thing we got when we plugged it in before, right? So let me see your TI-83, because I can't remember. You got to press in this junk in some order, and I have to figure it out every time. So you might have to figure it out too. Math 8 is still the end deriv, but is your function in your y1? Oh.
No.
If your function was in your y1, which I'll get sine t plus 0.5 e to the t. All right, so I've got the function in there now, right? To get, we don't have alpha trace, I don't believe. No. Shoot. Let's quit out of there.
On my calculator, it's programmed, I think. So what is
All right.
it on my calculator? Something different. It's like,
So to get the function in there, you have to go vars, y vars,
Yeah.
function, then the y1 can go in there. Then you hit a comma with respect to x, I believe, and then at pi. I think that's the order. Let's see if it works or if it gives me an error. Oh, yay. So the order is, when you see end deriv, function first. Now, if you don't have it in y1, you can do sine x plus 0.5 e to the x, comma. That x is just saying I'm taking the derivative with respect to x, right? And then the last one is we're doing the derivative at pi. So that's the order.
what the?
It was really loud. Last one.
Did you say you wanted
Do you want 63? Let's do 63 then. These are the ones that I really did not show you last class, so doing 2 problems is not too much. It says determine the points, if any, at which the graph of the function has a horizontal tangent. What's a horizontal line? Have a slope of?
Zero.
Slope equals 0. How do we get the slope of a tangent? Set the derivative equal to?
Zero.
That's all you do. 1y equals 1 over x squared, which is x to the negative 2. What's y prime?
-2.
X to the negative 3 or negative 2 over. Will that ever equal 0?
No.
So we have no horizontal tangent lines.
How do you know that's a zero? Because it's a zero in the denominator.
Okay. Right.
What drives a fraction to equal 0 is the top. So even if I have a big ugly fraction, all I really have to do is set the top equal to 0.
Oh, you can't do that, okay.
And negative 2 will never equal 0.
Got it.
But what about the bottom?
We have a vertical tangent line, or actually we don't have a vertical tangent line, because what happens at x equals 0 in this original?
No. Vertical aspect.
A vertical asymptote, exactly, or nothing. You're right. Y equals, is that x under the square root of 3
Yeah, square root of 3 times regular x.
times regular x? Okay.
It is?
Yeah.
Plus
Well, I
2
put it under.
cosine x. I was looking at it.
I need to put a space between that.
Yeah, or a parentheses or something. 0. So at least we only have to look from 0 to 2 pi, right?
Yeah.
Same,
Is that X under the? No.
that x is not under, yeah. So, just take the derivative, it's the same set of directions, we're gonna take the derivative, set it equal to 0. What's the derivative of root 3x? Root 3. What's the derivative of 2 cosine x? Negative 2 sine x, right? Set that thing equal to 0. Oh, trig is gonna come back and haunt us again. If I take the 2 sine of x to the right, divide by 2, I'm looking for where the sine equals root 3 over 2. Sine stands for over hypotenuse. Opposite is positive root 3 in quadrant 1 and in quadrant 2. 4, not 4. You're thinking cosine, weren't you? So it doesn't matter that the adjacent is different, but that is the angle because we're looking for the x, right? What is that angle? Which is pi over 3. And what's this one?
That is
2 pi.
2 pi over 3. It said determine the points, if any. We have the x values of those points. So we got to get the y values. Always go to the original for the y values, right? Square root of 3 times x. So square root of 3 times pi over 3. Square root of 3 times 2 pi over 3, would that be 2 square root of 3 pi? I worry about myself. Cosine of x. The cosine of pi over 3 is 1/2 times 2 is? I left a big blank for nothing. What is the, oh,
You might do 1 plus the other.
I have to say root 3 times root 3 pi over 3 plus 1. I did the first one, I just didn't do the
Is
second
this gonna
one.
be on the test?
It could be.
Is it gonna be this ugly?
It's not that ugly.
You just made like 4 mistakes in a row.
It's only because I just went brain dead.
Okay.
It's all right there. You
So
gotta
I
plug
plugged it into the first x, and now the cosine of this one already drawn is negative 1/2. So minus 1, because 2 times 1/2 is 1. Shoo.
Yeah, can I run up to the office and see if they have my parking pass ready?
Let's do that during break.
Well, I didn't.
So let's look back